Hey guys, so in the previous video, we talked about chi-square non-parametric methods for equal expected frequencies. Now in this video, we will focus about unequal expected frequencies. If you want to know about the equal expected frequencies, I will have a link inserted in the description box below. Just to have a quick review, we defined our terms in the past video, and we also define the major characteristics of the chi-square distribution. Now in this problem, we will have goodness of fit test for equal expected frequencies. Now let's read our example problem. The U.S. Bureau of the Census indicated that 63.9% of the population is married. Here it is. 7.7% widowed, 6.9% divorced and not remarried, and 21.5% single, never been married. A sample of 500 adults from the Philadelphia area showed that 310 were married, 40 widowed, 30 divorced, and 120 single. At the 0.02 significance level, can we conclude that the Philadelphia area is different from the US as a whole? Now this time, our expected frequencies will be unequal, unlike the previous problem. In this problem, we want to know that at 0.02 significance level, can we conclude that the Philadelphia area alone is different from the US as a whole? So to continue, here are the steps to solve this problem. Step 1. We need to state the null and the alternative hypothesis. And again, our null hypothesis should be a negation of a statement, meaning we will use words such as no or not. So in this case, the distribution has not changed. And our alternative hypothesis will be the distribution has changed. Step 2, our significance level. It is already given that in this problem, our significance level is at 0.02. However, in case it is not given, it is recommended not to go beyond 0.05. Step 3, select the select the test statistic. And in this problem, we will be using chi-square test. The formula goes chi-square is equals to summation of the quantity of the observed frequency minus the expected frequency squared divided by the expected frequencies. Now step 4, we need to formulate our decision rule after solving our problem. Now we need two variables, the degrees of freedom and our significance level. Now to solve for our degrees of freedom, we need to have the number of samples minus 1. In this case, we have 4 samples: married, divorced, single, and widowed. 4 minus 1 equals 3. Now looking at our chi-square table, let's point it, 3 and 0.2. So we get our critical value, which is 9.837. Now for our decision rule, if in case our null hypothesis goes beyond our chi-square value, which is 9.837, then our null hypothesis will be rejected. Now this is how it looks like. This area here is where lies our critical value. Now if our our chi-square value goes beyond our critical value, then it belongs to the area of rejection, meaning we will reject our null hypothesis and we will acknowledge our alternative hypothesis. However, if our chi-square value is below our critical value, then it belongs to the area of do not reject, meaning we will not reject our null hypothesis and we will acknowledge it. Now let's go to solve this problem. Since this is unequal expected frequencies, we need to calculate for the expected frequencies, each of them. For married, we need to get the 63.9% out of the 500 total population from Philadelphia. So To solve for this, we need to convert the percentage, this one, to decimal, also this and this. So for merit, 0.639 out of 500, we get 319.5 as our expected value. Here it is in the table. And for widowed, 0.077 times 500 equals 38.5. For divorced, we have 0.069 out of 500 equals 34.5. And for our single, we have 0.215 out of 500 equals 107.5. Now, as you can observe here, our expected values varies. It is not the same. This is what makes it unequal expected values. Unlike the problem we had before, wherein the expected values that we have are the same for all of the samples. Now, to solve for each of the chi-square, we need to get our observed values, observed frequency, which is 310 for merit, minus 319.5 quantity squared divided by the expected frequency, which is 319.5. To solve that, let's get our calculator. So for merit, we have 310 minus 319.5 quantity squared divided by our expected frequency, which is 319.5. So we get 0.2825, rounding it off. Next, for widowed, we have 40 minus 38.5 quantity squared divided by 38.5. Next, we have 30, let's clear this first. 30 for divorced, that is the observed value, minus the expected value, which is 34.5 quantity squared divided by the expected frequency, which is 34.5, and we get 0.5870. As for singles, observed frequency is 120 minus expected, which is 107.5 quantity squared divided by the expected frequency, which is 107.5. Okay, so this is the value that we get. Now looking back at the formula, we still have summation here, so we need to get the total for all of these values. To sum it up, just to check, 2.2825 plus 0.0584 plus, okay, never mind. So if we total these values, you will get 2.3814. Okay, now this value is our chi-square value. Now let's go back to our decision rule, step 4. It says here that our null hypothesis will be rejected if our chi-square value is greater than our critical value, which is 9.837. Our chi-square value is 2.834. Step 5. Compute the value of the chi-square statistic. So we already done that, and make a decision. Our computed value for chi-square is 2.3814, meaning it lies here in the area of do not reject, since it is lower than our critical value. So to conclude, the null hypothesis is not rejected. The distribution regarding marital status in Philadelphia is not different from the rest of the United States. Up next, we will have goodness of fit test for unequal expected frequencies. Now, if you find this video helpful, please subscribe and like this video. Thank you.